So when I talk about basic derivative, it's going to be something like things like, just so you know, all the back page I did not change. So
Okay.
so something is harder, something is actually, I went over it, so if you do watch it. Derivative of constant is, what do you think derivative of constant is?
Constant itself.
Nope. So think about constant as a function. And what's derivative mean? Slope.
The slope of the constant.
Slope of constant is what?
So it's just 1.
No.
0.
0. Yeah. So let's just think about, you have y equal to 2, right? That means it's a horizontal line at 2. Does that make sense? Slope is equal to 0 because it's flat. So derivative of constant is 0. Any constant. So d to the dx of pi is what? 0. Derivative of pi squared is still 0 because pi squared is like 3 squared. A lot of people did power rule on this, which is funny.
So would the power rule work on a constant? No.
The constant doesn't need power rule. They use constant multiple rule. So this is called the constant multiple rule. No, sorry, constant rule. Constant. Because derivative of a flat line is always 0. So it's called constant rule. So any number is 0. Any number. So how about the next one? The next one is the power rule. Right? The power rule says derivative of dx, x to the n is equal to, the n is going to move to the front, so this n is going to jump to the front. So this n right here is going to move to the front. So it's going to be nx. And this n is going to subtract 1, so it'll be n subtract 1. Okay, so this is a very, very useful rule. It's so useful, we're going to use all the homework today. And it's going to be something that's very, very, very important. Now, I'm going to mention this. If I have d to the dx of x, what do you think is? If I take a derivative of x, it's going to be what? Nope. What'd you say? 1. 1 is good because the slope of x is 1. Right? So derivative, remember, derivative with respect to x usually means slope of the functions, right? Slope of functions. And since you have, what dy dx actually, is the slope of the functions. So you have d to the dx of x is just 1. Slope of x is 1.
So dy over dx is the derivative of y of x. What does that mean?
dy dx is the same thing, so notation wise I'm going to show you. So we already know this notation, right? F prime of x. Do you guys remember this? This means slope of f, right? Is also equal to y prime, which is derivative of y. Also can be right in terms of implicitly, which is dy dx. And all three things are connected. They are the same. Same just means derivative. Same. They are the same. Derivative of function. So we're going to try to take a derivative of couple function. Let's say I take a derivative of x to the 8th. How do I take a derivative of x to the 8th? It's just going to be drop the 8 in front, right? And then 8 in the x to the 8 minus 1. So it'll be ax to the 7, just like Whitney says. He said, I got this. But Whitney still have to go back and redo the limit test. You have to understand everything from there. See the same way, or at least the same way. You know where to find the video, right? What if I want to take a derivative? And let me remind some exponential rules. And this is all the exponential rule from algebra 1. Algebra 1 is going to be very, very crucial here. A to the m times a to the n equal to a to the m plus n. 2. A to the m over a to the n equal to a to the m minus n. We actually did that yesterday. 3. Anything to the 0 power is 1. 4. Anything to the negative power is equal to 1 over a to the n. Or 1 over a to the negative n is equal to a to the n over 1. Fifth rule, a to the m to the n power is equal to m times n. The sixth rule says anything to the roots of a to the m is equal to a to the m over n. So this is algebra 1. But I will tell you, this becomes very, very useful here. It's very useful because we get to use it all the time. Right? Even this is going to be very useful. Everything here is useful. But the most common thing that you will be using is those 3 rules, the exponential rule. So let's just say if I want to take a derivative of these functions of, what do you think, how do I take a derivative of this? Derivative is correct. So before you take a derivative, you're going to follow the rule 6 to change that, right? So x to the 5 over 2, because that's the exponential rule as actual definition of radicals. And if I take a derivative of that, just take that 5 over 2 to the front, and you say, okay, well, that's 5 over 2, x to the 3 over 2, because subtract 1. Subtract 1 is 2 over 2. So 5 over 2 subtract 2 over 2 is equal to 3 over 2. So that's my final answer, 5 over 2, x to the 3 over 2. Are we okay? Now I want to go back to mention this rule. So can you put like a very, very important things here? So here, make sure is numerator. So it doesn't work with 1 over x squared. It only works if you move it to the top so you can take a derivative. Okay, it only makes sure it's numerator. So x to the n has to be numerator, not 1 over x squared. So I'm going to show you how to do 1 over x squared though. let's just say if I have f of x is equal to 2 over x cubed. Then you say, oh, okay, let's take a derivative of this. But what you're going to do is you're going to rewrite this. You rewrite this, right? How do I rewrite it? This is on denominator. I cannot use power rule.
X to the negative 3 power times 2.
To the x to the negative 3, right? Does this make sense? I can move down here to up to become negative exponent. Now, the teacher says you're not allowed to have negative exponent. Remember, there are certain things that we lie to student. Those are one of the things. Here, we actually have negative exponent, so we can take a derivative. We have to make sure it's on the numerator before we take a derivative. Now, I'm going to do prime. That means 2 times negative 3 times x to the negative 4. Does that make sense? Is equal to negative x to the negative 4. That's equal to negative 6 x to the 4th. So f prime of x is equal to this. Does this make sense? You cannot take a derivative when the x is on the bottom. I always move to the numerator. How do I move? Use the negative exponent rule. This rule right here. If you have it on the bottom, move to the top. Becomes positive. Today's easiest homework that even anybody can do it. Like even the worst people can do it. Are we okay here? I did forget to mention about constant multiple rule, so I'm going to mention that here. If I take a derivative of a constant times f of x, you can always take the constant out like this. So you can take the constant out, like what I did. I take the 2 out, and I just take a derivative of the x to the negative 3. So c f prime of x. So you can take a c all the way outside, and it's just going to be c f prime of x. This is called constant multiple rule. Constant multiple rule. Pay attention to the parentheses. The hardest part you're going to have is not going to be the calculus. It's always the algebra. If you cannot see the small difference between each things, then, so we're going to say original questions, original functions, and now we're going to say y is equal to 5 over 2x to the third, and then y is equal to 5 over 2x to the third, and then y equal to 7 over 3x to the negative 2, and last one's y equal to 7 over 3x to the negative 2. Now, do you see that there are small difference at each questions between A and B and C and D, right? The parenthesis location. Do you see that? So what I want to do is, first thing I always go to rewrite process. I rewrite them. So let's rewrite them. So y can take a derivative. What's wrong with this situation? Why I cannot take derivative this morning? Why I need to rewrite? Huh? X needs to be on numerator. So how do I change to the numerator? Does this make sense? I rewrite to the top. Now I'm going to take a derivative. If I take a derivative, I just ignore the constant. I'll take the derivative of that x to the negative 3 is negative 3 times x to the negative 4. So that's e equal to negative 15 over 2, and then x to the fourth. Sorry, I'm going to do x negative 4 first. And if I simplify, it's equal to negative 15 to x to the fourth. How do I rewrite the second one? Be careful. What's the difference between this one and last one? Parenthesis. How does that affect in this case? If I rewrite, what am I going to get as opposed to 5x to the negative 3 over 2? What would you get?
You get 2x to the negative third power, right?
What would you get?
5x to the negative 3 over 8.
Right. So remember, you need to move to the numerator, right? So before I do that, I'm going to expand this. That's going to be 2 to the third power is 8, x to the third. And then I'm going to move to the top, 5 over 8, x to the negative 3. Now let's take a derivative. Negative 3 times 5 over 8 times x to the negative 4. That's equal to negative 15 over 8 x to the fourth to the negative 4. Or negative 15 over x to 8 to x to 4, 8. Am I going too fast?
So once you get the x out into the numerator, and after you do all the derivative stuff, you can just move it back to the denominator.
Now move back. Now you can prefer to be positive exponents. Because a multiple choice answer is not going to have a negative exponent usually. It's going to be always positive. How do I rewrite the third one? This one's easier.
It's just 7x squared over 3.
7x squared over 3, yep. Because only the x is negative 2, not the 3. A lot of people think that's different. So y prime is equal to 7 over 3 times 2 times x squared. So that's equal to 14 over 3 x squared.
Wouldn't it just be x and not x?
Oh yeah, x. Yeah, my fault. It's just x. Good job. I was really sleepy. Keep on yawning. You want to take a derivative of the last one? This one's actually easy. What'd you get? Nobody can get anything?
Got an answer, but it doesn't say very plausible.
What's your answer?
126x?
Yep, that's our answer. Why? Let's move it.
Because
7 times 3x to the 2, right? Because we move up to become numerator, it becomes 2. So 7 times 9x squared equal to 63x squared. So that's a dy dx is equal to 126x. I didn't finish the last part. But last part's right here. Just you can take a picture of this before you go. And I'll